Hello and welcome to Advanced Digital System Design playlist. Today we're gonna start about the analysis and design of the clocked sequential circuits. We know the clocked sequential circuits are also called as synchronous sequential circuits. These circuits are represented by usually two models, Moore model and Mealy model. In Moore model, the output depends only on the present state of the flip-flop, while as in Mealy model, the output depends on both the present state of the flip-flop and input of the flip-flop. In Moore model, the output depends only on the present state, and in Mealy model, the output depends on both present state as well as input of the flip-flop. Now let us distinguish between Moore model and Mealy model. In Moore model, the output is a function of present state only. In Mealy model, the output is a function of present state and input of the flip-flop. In Moore model, input change does not affect the output. In Mealy model, input change may affect the output. The Moore model requires more number of states for implementing the function. Mealy model requires least number of states for implementing the same function. So Mealy model requires least number of states for implementing the function, while as Moore model requires more number of states. So we usually prefer Mealy model as it requires less number of states for implementing the function. Now let us here we will focus mainly on Mealy circuits. Now let us discuss about state table and state diagram, what it actually is. State table represents the relationship between input, output and flip-flop states. State table usually has the relationship between, it gives the relationship between the input, the output and the flip-flop state. The state diagram on the other hand is a graphical representation of state table, or it's a pictorial representation of behavior of sequential circuit. Here each state is represented by a circle, and transition between states is indicated by directed lines connecting the circles. As shown here in figure, the transition between states is shown by directed lines, and each state is shown by a circle, represented by a circle. A directed line connecting a circle with itself indicates that the next state is same as the present state. It means that if a directed line is connecting a circle with itself, it indicates the state is same as the present state. Here it is called the self loop. Usually the directed lines are labeled with binary numbers separated by symbol slash. The input value that caused the state transition is labeled first, and the output value during the present state is labeled after the symbol. The directed lines usually are labeled with the binary numbers separated by a slash. The input value is written first, while as the output value during the present state is labeled second after the symbol slash. Let us take an example which is given as determine the state table and state diagram from the sequential circuit. So we are given the sequential circuit this, and we have to determine the state table and state diagram. What we are given is the sequential circuit and characteristic equations. So from these characteristic equations we can determine the state table. If you are not given with this characteristic equation, we can simply determine the equations from the sequential circuit. Here the output Z can be found by this AND gate. It is the AND of X input and A input, so Z is XA. Now the value of dA can be obtained. dA is equal to here A and X bar from this X through inverter. So A OR of X bar, A plus X bar, dB. Now dB is equal to, dB is the AND of first AND of B bar and X, and AND of X bar and A. Then it's an OR of x bar a plus xb bar. So db is also now known. So now we can simply find the state table by substituting 4 combinations in this characteristic equation. For example, we can find dA from substituting a is equal to 0, b is equal to 0 in these equations. For a is equal to 0 and x is equal to 0, we get dA is equal to 0 plus 0 bar. We get 0 plus 1 is equal to 1. So we write 1 here. For b is equal to 0 and x is equal to 0, we write 0 bar plus 0 bar, a is 0, plus 0 plus b is 0 bar. That means 0 bar is 1, 0 bar is 1, 1 into 1 is 1, plus 0 into b bar means 0 into 1 is equal to 0. So 1 plus 0 is equal to 1. So we write 1. Similarly, we can do it for when x is equal to 1. We can write here a is 0, x is equal to 1. So 0 plus 0 is equal to 0. So we write 0 here. Similarly for this, x is equal to 1. So 1 bar is 0. 0 into anything is 0. X is equal to 1 and b bar is equal to 0 bar is equal to 1. So 0 plus 1 is equal to 1. For z, we can substitute the values. For x is equal to 0 into a is equal to 0 is 0, and x is equal to 1 and a is equal to 0 is equal to 0. Similarly, we can do it for 0, 1, 1, 0 and 1, 1 combinations. We can derive the state table. From the state table, we can easily determine the state diagram. That is, first we go for 0, 0. For 0, 0, next state is 1, 1 when input x is equal to 0. For 0, 0, next state is 1, 1 when input x is equal to 0. And output for that value is z is equal to 0. At 0, z is equal to 0. And 0 when present state is 0, 0. The next state is 0, 1 when input is x is equal to 1. When present state is 0, 0, next state is 0, 1. 0, 1 when input x is equal to 1. When input x is equal to 1, so we write 1 here, slash the output for that x is equal to 1 is equal to 0, so we write slash 0. For 0, 1 present state, when the present state is 0, 1, the next state is 1, 1 when input x is equal to 0. For present state 0, 1, for present state 0, 1, next state is 1, 1 when input is equal to 0, when input is equal to 0 and output is equal to 0. So 0 by 0, 0 slash 0, 0, and for 0, 1 the next state is 0, 0. For 0, 1 next state is 0, 0 when input x is equal to 1 and output is equal to 0, 0. For 1, 0 next state will be 1, 0. For 1, 0 next state will be 1, 0 itself, so self loop at 1, 0. For input x is equal to 0, for input x is equal to 0 and output is equal to 0, output 0, 0 slash 0. For 1, 0 next state will be 1, 1 when input x is equal to 1. For 1, 0 next state will be 1, 1 for input x is equal to 1 and output for x is equal to 1 is 1, so 1 slash 1. For 1, 1 the next state will be 1, 0. For 1, 1 the next state is 1, 0, so this arrow when input x is equal to 0, when input x is equal to next state will be 1, 0 when input x is equal to 0 and output is equal to 0. For 1, 1 next state will be 1, 0. Next state will be 1, 0 itself when input x is equal to 1 and the output for x is equal to 1 is equal to 1. So this is 1/1 and 0/0, because for 1 1 the next state is 1 0 1 0. For input x is equal to 0, for input x is equal to 1. This completes the state diagram of this example. That's all for this video. I hope it's informative for you. I'd like to thank you for watching, and please do like and subscribe.
Subscribe now and click the bell icon. Never miss an update.